Okay, so let's begin with any questions. Trevor, welcome. We're beginning with any questions you might have. And Mason, welcome. Are there any questions from chapter 0? You know, what we've been going through in class the last few days. And, you know, I'm going to share my screen because, hi, Jared. We're getting more people in. This is good. But I'm going to share my screen because I want to write a message on there right off the bat. So you guys should be seeing my screen right now with the big question mark in the corner. Let me know if you're not. Okay, welcome Matt Singer, Brad Nimitz, and Maki. Welcome. So we're at the point where you can ask questions before we start the new lesson, and if any of you want to ask any questions about that Chapter 0 stuff, you can. I'm going to remind you you can send, if you want, I mean, if you're connected, you can just ask a question audibly and I'll receive it. But if you're on the video section and you want to send me questions, you can do it this way. Welcome, Meredith. Glad to have everybody here. So anybody have any questions you want to go through on from Chapter 0 yet? Before we get going on Lesson 1.1. I'm not hearing any. You can always just interrupt and ask me a question. Or if you want to use the chat, remember, if you go to the top left of your screen with your mouse, you'll see that little blue, like a notepad. If you click on that, it'll open a chat window on the right, and you can send me messages that way. Or, depending on, you can also use the Q&A button, and if you click on that, that's that Q&A that Professor Johnson showed us last time. And then remember, up in the center of the screen, you can mute your mic. You can do different things there. Okay? So, I'm not hearing any questions, so I'm going to get started. And the first thing we're going to do here, I got to remember where I'm looking. Not that one, but here's the title of our first of our chapter, the beginning of our Chapter 1. It's the first lesson. It's on page. Actually begins. Okay, I'm getting some questions here. Actually begins on page 2 of the book. Chapter, it's 1.1, the Cartesian plane and the distance formula. And I better check on my text message here. Oh, we do have a question. Okay. On 04, problem number 57. So I'm going to begin with that. On 04, problem number 57. Okay. So I'm going to start a slide. So here's the question I was asked about, 0.4, number 57, and I'm getting there. Okay? Yeah, use synthetic division to complete this. Okay, so the problem is x cubed minus 3x squared minus 6x minus 2 is equal to x plus 1 times what? So that's the problem, and we're supposed to use synthetic division to do that. So with synthetic division, remember you want to set up a bracket, and then inside the box you want to put the coefficients of the terms, and you got to make sure you have all the powers of x represented. So we've got what, a 3 here, then a 2, then a 1, then a 0. So we don't have anything we have to worry about. The first coefficient is a 1, then we have a negative 3, then we have a negative 6, and then we have a negative 2. Now what you put outside here depends on this, and that x plus 1 is equal to 0. I'll just write that over here on the side. Whoops. When you have x plus 1, you want to set that equal to 0, and you can see that that really implies that this should be a negative 1 out here. So now we're set up for our synthetic. Bring down the first coefficient from the bracket, 1. Take this thing out here, take that negative 1 times 1 and put the answer here. Now add that column you just added to. Now once again take the negative 1 out in front here and multiply it by that. That would be a positive 4. Now add the next column of coefficients. Again, multiply negative 1 times negative 2 is 2, and add the last column. And that last one, that's your remainder. So in other words, that tells us that x plus 1 divided in evenly with no remainder. And then all I have to do is interpret that thing above the wavy line. Since we were doing a cubic, what this means is x squared minus 4x minus 2. And that's what would go up here. So there, we used synthetic division in order to complete that factoring job that that was in problem number 57. Excuse me. So let me just double check here. Did I get any other messages? Questions? I don't believe so. Does anybody else have a question from Chapter 0 that you'd like to look at? And whoever sent me that problem 57, hopefully that answered your question. If not, speak up, send me another message or something so that I know you got what you were looking for. All right. I'm going to move forward. Remember, this is all being... we got another message. Let's see what we got. Yeah, we do have another one. 5, number 15. Okay, we'll do that one next. So 05. I guess I better change colors. Go back to black. 05, number 15. Make sure I got the right one there. Yeah. All right, 05, number 15. I'm getting there. And it says, perform the indicated operations and simplify. So here's what the problem looks like. It's going to be kind of large, so I think I'll put it down here. We have 1 over x squared minus x minus 2. And then from that, we're supposed to subtract x over x squared minus 5x plus 6. So we're supposed to perform the operation, do the subtraction, and simplify. Well, we can't do anything until we get a common denominator, can we? So the first step, we need to get a common denominator, but I can't really see the common denominator until we what? Factor those denominators. So let's factor this guy here first. It's probably pretty obvious that it's an x and an x, and we need what? A -2 for a product, so that would be what? -2 plus 1. Will that work? Yeah, -2 times 1 is -2, and then you got to do the what? The inners and the outers. The inners, -2x, the outers, +1x. -2x plus +1x really is -1. Yeah, we got it. It checks. And now this guy, again, x and x. This time we have a product of 6 that could be a +3 and a +2, or it could be a -3 and a -2. And if you look at this middle sign, it's got to be the latter, because now the middle term is going to work out. A -3x plus a -2x is a -5x. -3 times -2 is +6. We got it. So now, what's the least common denominator for those two fractions? We need what? An x minus 2, an x plus 1, and an x minus 3. This factor over here is repeated. So we need an x minus 2, an x plus 1, and x minus 3. What are we missing from the first fraction? I see we lost our image, huh? Okay, so let me try resharing again. Hopefully you guys are seeing everything again. I don't know how long I was off there. All right, so the first fraction, we need what? Here, let me write. Our LCD is x minus 2, x plus 1, and x minus 3, right? That'll give us a factor that represents both, that's enough factors to represent both denominators. You see we're missing in the first fraction an x minus 3. That means I got to take the top times x minus 3 and the bottom. And in this one, what are we missing? An x plus 1. So I'm going to take the top and bottom times x plus 1. So now we'll have both fractions will have the same denominator. Okay. Excuse me. So, good news. We're going to have a fraction with the LCD because they're both going to agree. So I'm going to put the denominator in right. The numerator, well, the first numerator is 1 times x minus 3, which is x minus 3. And the second one is x times x plus 1. But be careful, that's a minus there. So this is really x squared plus x. But do you see that because of that minus sign up there, this has to stay in parentheses. So what's that equal to? By the way, if you guys are not seeing the screen, somebody let me know. I believe, from what I can tell, everything looked going now. I don't know, we lost it there for a second, but thankfully we got it back. So on the top, this is x minus 3, and then it's minus x squared minus x, right? When you do a distributive property, both of these have to be subtracted. All right, well, can we combine any of those? Yeah, well, x minus x is gone. And what we're going to have left up is negative 3 minus x squared all over x minus 2, x plus 1, x minus 3. The only thing we might want to check is whether or not it's possible to is it possible to factor the top and therefore simplify this a little bit more? Well, we could take a -1 out, but that's really not going, that would give us, I mean, that could be written as -1 times 3 plus x squared, but that doesn't really lead us anywhere. So I'd say we're good with that thing in the circle. So sorry, I couldn't quite fit that all on the screen, but the one we were just working on was 0.5, number 15. And again, any questions or follow-ups? No. Yeah, I think I've got the questions that came in by text message. Okay, I got a message from Brandon, but Brandon, you sound like you are back online again. Okay, good. Thanks for the message, Brandon. All right. Let's now get started on the new. So one more time, we are starting our first chapter, first lesson, 1.1. This is almost all review, but it's really important stuff. The Cartesian plane, good old XY axis, how to plot points. I'm not going to go through what the origin is and all of that. I'm really assuming that we have no problem with everybody knowing that. But there are some really important things that we need to review. Okay? That's the one we did. Okay, let's start here. So, the first thing I need to talk to all of you is the distance formula. Okay, and maybe, yeah. So, I'll tell you what, I'm just going to scrap this and we're going to make a new drawing. So we can get to this a little bit better. Now I don't have my keyboard. So I'll tell you what, let's just make a new page. So if we have a grid, a coordinate grid, and we just, the idea is we want to develop a distance formula. So if we just pick a point, and we need 2 points, and I'm just picking 2 kind of generic points, okay? Because the whole idea of a distance formula is we need it to work for any 2 points. So I'm just going to call this point x1, comma, y1. And let's call this one point 2, x2, y2. And we want to find a way to find the exact distance between those points. So what we want is what? The distance from there to there. And what we're going to do to help us out here is we're going to make this into a very familiar. Whoops. Little problem here with leaning in the wrong place. Sorry about that. Something. Sorry. So what I'm going to do is I'm just making a vertical and a horizontal part there to make this into a right triangle. Now you all know that a right triangle has a very important thing, good old Pythagorean theorem, right? One leg squared plus the other leg squared equals the hypotenuse squared. Well, this is what we want to find out. This distance, I'm going to just call it D right now. This distance, that hypotenuse is what we want. And we could think of this as the A and this as the B. What are the coordinates of this point right here? Well, that point is directly below this point up on top, so wouldn't that have to have an x coordinate the same as that point up there? That's got to be x2. And the height of this point, doesn't that have to be the same as this point over on the left? So that's got to be y1. So now we know the coordinates of that point. Okay, so what's the length of this little leg over here on the right? Well, it goes from y2 to y1. so it's just y2 minus y1. That's the length of that leg. And this leg goes from x1 to x2, so this is just x2 minus x1. Okay, now let's do the Pythagorean theorem. We've got x2 subtract x1, that leg squared, plus this little leg, y2 minus y1 squared equals the hypotenuse squared. So that's just the good old Pythagorean theorem using coordinates. But we don't want to know d squared, we want to know d. So how can I get that down to d? I could take the square root of both sides, right? And then all we have to do is take the square root of the left side and there it is. That's called the distance formula. And I'm sure you guys all had that in your previous algebra class, but that's huge, very important. I'm going to put a rectangle around that, meaning you really have to know that, okay, the distance formula. So that if I give you any two coordinates, can you find the distance between the 2 points? So I have an example here I'd like to look at. So let's look at the bottom of this page here. So if I gave you these 2 points, 5, 2 and negative 3, 7, could you find the distance? Sure. And by the way, just to make this a little easier, we could think of this guy. We could think of this guy here as x1, and this is y1, and this is x2, and this is y2. So we could just plug them right into that formula. You know, x2, negative 3, minus x1, 5, squared, y2, 7, minus y1, 2, squared. And then you just got a little subtraction here. What's negative 3 minus 5? It's negative 8, squared. And then 7 minus 2 is 5. So you wind up with 64 plus 25, and you get the square root of 89. That's it. That's the exact distance between these 2 points. So I know you've all done that in the past, but so what have we covered? You need to know the distance formula, this thing in the rectangle on this page. And then, of course, you need to be able to apply that so that if I give you any 2 points, like we did right here, that you could actually come up with the answer. And by the way, the square root of 89 is a good answer. You don't want to, I mean, I don't want you to give the decimal equivalent of that. Why? Because the square root of 89 is exactly correct. I'm sure if you really needed it, if you were going to the store and you had to have something that long, yeah, go ahead and get the decimal equivalent. But in math, if you can give the exact answer, you're better off leaving it in that form. Anything we might look at is there anything we can do to simplify the square root of 89? That is there any perfect square number that could divide evenly into 89? You know, like 2 squared is 4. Does 4 divide into 89? No. 5 squared is 25. Does that divide into 8? No. 6 squared is 36. You know what I mean? You would just check through that list and you won't find any in this case. Okay, so that's the distance formula. Let's call this the second formula today. Well, let's first do this. Okay, another important formula is to be able to find the equation of a circle. And I'd like you to all think back to your geometry days. What is a circle? Isn't a circle just all the points that are equidistant from a given point? The given point would be the center. and the equidistance would be the radius of that circle. So if based on the distance formula, that's just a distance formula because it's equidistant from that point. So you so using that as our center and that as our equidistance, what was here? Let's just write this out again. Distance equals. This is just a repeat. This is our distance formula again. Okay, now, in this case, the equal distance is the radius. X2 is, it's like the difference now is our 2 points are X and Y, and the other point is the center, which we're saying is H comma K. So now all I got to do, so where X2 is, we'd have an X. Where you know what I mean. Where X1 is an H. This would be Y2, Y1. So really, I mean, it's the same thing. It's just that we're using these instead of X2, Y2, and X1, Y1. So now this becomes okay. And if you can leave it like that, or you can square both sides and get this. This is the one usually you will see like in the textbook. So let me put a rectangle around that. So that's the equation of a circle. Remember this info that's on the top. That's the equation of a circle whose center is at H comma K and whose radius is R. So for example, let's take what if we have a circle whose center is located at 3 comma 2 and whose radius is I don't know, let's say 6. So really all we got to do is plug it in, right? Radius 6 squared, so this would be 36 and this would be so in other words, this is your H, that's your K, and that's your R. And you just plug them in, boom, there's the equation of a circle whose center is at 3, 2, and whose radius is at 6. Let's do one kind of in reverse. This time I'm going to give you the equation. Can you find the center and the radius? So here's a circle. I'm going to write it a little differently. X plus 5 squared plus y minus 4 squared equals 121. So you should see, if you look at this, that is in what? That format up there? Sure, I put the r squared on the other side, but don't let that throw you off. I've got the r squared on the right here. Well, what's the square root of 121? 11. So now we know the radius. Now, be a little bit careful. What's the center of the circle? What number is being subtracted from x? Actually, isn't a negative 5 being subtracted? Because what happens when you subtract a negative 5? You get x plus 5. So let me just say the radius circle we already said is 11, and the center is located at negative 5, and then what's being subtracted from y? 4. All right, I got some messages here, so let's see what we got. Okay, the question is, do we have to simplify the previous equation, or can we leave it like it is? In the case of the circle, you want to leave it in the standard form. So I'm not sure which equation you're referring to, but I would say all three of these at the top, D equals R squared, these are all good. You want to see that format so that when you see it, you go, aha, that's a circle, and I can quickly identify its radius, and I can quickly identify its center. So I believe that's what the person was getting at with the text message question. Okay. So far, what have we done? We've done the distance formula, and now we just applied the distance formula to all points equidistant from 1, which is good old circle. So the distance formula and the equation for a circle, I hope you can see, are forever tied together. And really, what ties them together? The good old Pythagorean theorem. Okay, now we're going to move on to a third, pretty simple one. I'm not going to redo everything, but I just want to show you this, and that is, it's called the midpoint formula. So again, if we take generic points, I'll call the first one x1, y1, and the second one up here on the right, x2, y2. Can you find the blue point, that is, the midpoint of that segment? Half, so that these two parts are exactly equal. Well, by a little sketch I made, I think you can see real quickly that if I just draw a vertical line and a horizontal line, we have what? Haven't we divided this leg exactly in half? And if you look over here, we've divided the right leg exactly in half. Therefore, all we've really done is cut each we found the average of the x-coordinates and the average of the y-coordinates. And look, that's what the midpoint formula is. By the way, MB stands for midpoint. All you have to do to remember the midpoint formula is the x-coordinate of the midpoint is the average of the x-coordinates, x1 plus x2 divided by 2, comma, the average of the original y-coordinates. Easy to remember that way. So that's three formulas from the past. Distance formula, the standard equation for a circle, and number 3, this one here, the midpoint formula. All very important. You're going to need those. Okay. Again, ask questions if you want. You guys don't all have to have your mics muted. I see you all do. That's polite of you, but I'm perfectly okay if you want to just speak up and ask me a question, okay? All right, then I'm going to go, what we're going to do is we're going to start doing some problems from the assignment. So if you look at the end of lesson 1.1, the exercises begin on page 8, and the first one I've picked out is number 14. And number 14 says, plot the points. Well, I'm not doing, I don't care if you guys you don't have to do that part. Okay, I figure you've got to be able to plot ordered pairs by now. But then go on and find the distance between the 2 points and find the midpoint. Okay, I didn't do the point here. How does one find the distance? Use the distance formula. You'll notice up here that I have, with this 1 and this 2 up here in the top, I've identified which one is 0.1 and which one is 0.2. You can do it either way you want. It'll work either way. But I urge you to nail it down so that you don't accidentally switch halfway through the problem. So now I know this is x, y1, this is x2, y2. You got them switched, it'll work just perfectly fine. Why does it work when it's switched? Because you're going to be squaring those subtractions anyway, and anytime you square a number, if it was negative, it's going to be positive anyway. So it really makes no difference. So anyway, you can see I took x2, 0, minus x1, negative 2, so 0 minus a negative 2, then that's squared, plus y2, square root of 2, minus y1, 2, that's squared. Okay, what's 0 minus a negative 2? That's actually 0 plus 2. And what's 2 squared? 4. Now this one's a little more of a challenge. How do you square the square root of 2 minus 2? Well, you do it the long way, like I did over here on the right. You just whack it out. Do all the handshaking. Square root of 2 times square root of 2 is 2. Square root of 2 times negative 2 is negative 2 times the square root of 2. Negative 2 times the square root of 2 is another negative 2 times the square root of 2. And finally, negative 2 times negative 2 is plus 4. And then, of course, 2 plus 4 is 6. And then you've got this thing doubled, so it becomes negative 4 times the square root of 2. So you'll see I've put that answer in there. And of course, you can combine the 4 and the 6 to make 10. Now that's kind of an awkward answer, but that's it. I'd actually prefer you leave your distance that way. Okay. And as far as the midpoint, let's quickly do that. What's the midpoint of these two up here on the top? The average of the x-coordinates, so that's negative 2 plus 0 over 2. And the average of the y-coordinates, 2 plus square root of 2 over 2. And then you can just do a little bit. What's negative 2? It's negative 2 over 2, which is negative 1. Here we really can't do anything. So I would just leave. This would be my answer for the midpoint for number 14. So there's one sample problem from the assignment. Okay. And hopefully there's no follow-ups. Let's go do another one. I didn't mean. What I mean is I hope you got what I just did. Okay. Number 24. So this is totally different. It says, given these 2 points, and notice one of them is half done. The first point is 2, negative 1. The second point is x, comma 2. It's a variable. And they want you to find a point which is 5 units away. Hang on a minute. Yeah, find x such that the distance between the two. So what does x have to be for the distance between the 2 points to be 5? Okay. So first I did a little geometric thing here with a compass. Here's the point right here. Here, let me change that to blue. Right here is the point. Whoops. Right here is the point. I don't know, it's not changing to blue. Sorry about that. All right, let's use red. Here is the point 2, negative 1. Now, I need a point, it's called x, comma 2. So I don't know what x is, but I do know it's too high. And that's what this line's all about. Okay, do you see how that's all up to? So all I know is my answer is somewhere on that dotted line, and I know the distance is 5. So guess what I did? I set the compass up. Yeah, I can't move it right now, but I set the compass up so that it spread 5 apart, and I drew an arc with this at the center. And you notice I got 2 points. I got that one and that one. There are 2 places where that arc crosses the line. So in other words, we should get 2 answers. And hopefully you see geometric. Yeah, there's two values x could be and still be up to where the distance is 5. So this would be 5, and so would this. By the way, what does x look like it is over here? 1, 2, 3, 4, 5. It looks like this is 6, comma 2. So x is 6. And over here, what is x? Negative 2. So just looking, now that's not the way you're supposed to solve it, but I just wanted to show you should get 2 answers. Now let's do it algebraically. That's not the right one. Sorry, I'm in the wrong place. Here we go. I apologize. So here's the problem, the same problem, only now we got to do this algebraically using the distance formula. So there's our distance formula. And now we know what d is. D is 5, so we stick a 5 in there. We know what x1 and y1 are. The only thing we don't know is what x2 is. So that's just a bare x. So do you see how in here there's only one variable left? And it's x. So all I did, this is my point 1, this is my point 2. So when I did x2, that's an x. x1, that's a 2. y2, that's a 2, and y1 is a -1. So you can see I just plugged it in, crank out. Okay, what's x minus 2 squared? Let your hand shake it out. Let's do it on the right here. Right? X times x is x squared. X times -2 is -2x. -2 times x is -2x. And -2 times -2 is +4. So when you combine the -2x and the -2x, you get the -4x. So you see where I got this part? X squared minus 4x plus 4 is what I got right over here. Where's the 9 from? Right here. What's 2 minus a -1? 3, and 3 squared is 9. All right? So combine 4 and 9 is 13. Now, square both sides. Why? So we can get that root out of there. That gives me this. And then subtract the 25 so that you have the whole thing equal to 0. And then, lo and behold, that thing is factorable. That x squared minus 4x minus 12 is factorable. And sure enough, there's the two factors. What are the two answers? Well, when x minus 6 equals 0, that turns out to be 6. The other one is 2, -2. Does that sound familiar? Look, that's exactly what we surmised was the answer, looking at it from a geometry point of view. So, nice check. X is -2, x is 6, and that's exactly what we got right here. Whoop. So, sorry. That's exactly what we got right down there. So that's number 24. We've looked at a couple examples. Yeah, this is some more. This is a problem I made up, but it's some more practice on do you get the standard form of a circle. So what if I asked you this question? Find the equation for a circle whose center is at 3, 5. And whose radius is 7. So I didn't write it in here, but here's what you really need to know. Remember this guy? Yeah. That extra fork there shouldn't be there, but I can't erase it now. And that is hello, and that's equal to r squared. Remember that? That was, and this is supposed to be squared right here too. That's that standard form of a circle. So you notice all I did is plug in 3 for h and 5 for k. And then the radius is 7, so what's the radius squared? 49. There it is in blue. That's the equation of a circle whose center is at 3, 5, and whose radius is 7. And if you know your circle equation, you can see that that can be done pretty quickly, can't it? Okay, and then that brings us to our assignment. Our assignment for this section, I'd like you to do 1 to 33, the odd-numbered problems, and that's beginning on page 8. And by the way, whenever that happens, you guys can always let me think here. Well, never mind. I've just told you stop. 33 is your last problem. So Now, to finish this off, I need to know if there's anything that needs clarifying. So let's see. Oh, we got a little difference in a textbook here. I got to see what Maki said. In my textbook, number 14. What, isn't that what I did? Where was number 14? This one. Oh, yeah, looks like I copied it wrong. Sorry. So Maki, to answer your question, you're right. I didn't copy problem 14 exactly correctly. So you won't see, well, you don't see it anyway because it's an even. So yeah, you're right. I did a slightly different problem. That is correct. Your book is fine. Brandon, I really mean all the odds this time, not every other odd. Okay? Thanks for the good question. Okay, let me see if anybody put Q&A questions in. Nothing up. Okay. Okay, we just got a text message coming in. I'll take a look at that next. When are these problems due by? Whenever I give an assignment like that, it's due the very next class. And that would be tomorrow. So what do you have? What is it, 16, 17 problems that you should have. As close as you can, have them completed by tomorrow morning at class time. And remember, sometimes I may collect these, not very often, but you always want to be ready and have them as complete as you can. Now, if you do get stuck on something, try to work as far as you can, and then when I open the class with questions, jump in there and ask me to go through the problem. Anybody else have questions? Thanks for participating and asking and responding with questions. I really appreciate it. All right, then I'm gonna hang it up. Thank you very much. Remember, in about 5 minutes, I will have the link to this video on our Moodle webpage. Thank you.